each orbital can hold 2 electrons, but they must be in opposing directions. Okay? And how we're going to do electron configuration over here? So electron configuration is writing the following order: energy level. So we start with the lowest energy, and every single element when they start over here. So remember, let's talk about this will be the streets, and then we have the number of the house where the elements located at, and we have a number of electrons and the orbital. So don't put commas or lines when you're writing the electron configuration. So we have the energy level first, then we have the orbital sublevel, and then we have the number of electrons in this sublevel. Okay? To work with the electron configuration, you can use the alphabet principle diagram. So the alphabet diagram shows you the electron configuration when increasing the energy over here. So the electrons are arranged about the nucleus in a regular manner. The first electron feel the energy sublevel closest to the nucleus. And we continue filling each sublevel until it's full, and then start filling the next closed sublevel. Okay? So the orbital are filled in increasing order of energy. So we can start 1s, and then 2, 2p, 3s, 3p. So increasing energy. This is important. See here that we have more energy levels. Okay. So let's go to helium. I could use the alphabet diagram, but I want to use the periodic table as I explained it to you in the first video. So if you go to the row 1, so that will be the first level of energy. So in the first level of energy, you have to pass through all the elements you have. So we have block S in the periodic table, have block D, we have block P, and we have block F. So in this block S, we have 2 elements in the first level of energy. So I have a 1. So the first level only have, if it's 1, will be only sublevel S, right? This is the blocks that we have over here, right? So we have, 1s, and since we have a 2, will be 2. Okay? So 1s2. If I want to write down all the quantum numbers for everything, so 1 is the level of energy. So one of those electrons, so let me draw the orbital over here. I have in this direction and the other in the other direction. Remember this? Exclusion, Pauling exclusion. So, okay, so L, we know that L is what? N minus 1. So L is 0, which is the orbital S. So it's 0. ML is over here, right? Goes to negative L to positive L. So it's 0. So I only have 0. So ML is 0. MS, so up, first electron, positive half. Okay? So then we go to the second electron. So we're going to have in the same level, same sublevel, same M sub L, but different spin. Okay? Easy. And good. Okay. So when filling degenerate orbitals, the most stable configuration corresponds to the one that presents the largest number of electrons with the same spin. So electrons fill each orbital singly before any orbital receives a second electron. That is Hund's rule. So that means if I have 1, 2, 3, and I have 5 electrons to fill it out this. So I'm gonna have 1, 2, 3, 4, 5. You cannot, let's put a 6, just to, 6, no, 4, just to help here. So I cannot do this 1, 2, and then 3, 4, and leave one blank here by itself. So I have 3 orbitals, remember? So this, it's wrong, okay? Because we need to take in consideration the energy. So Hans rule, okay? So let's go to this one. Indicate 4 quantum numbers for the most energetic electron in copper. So you can use the diagram and do your electron configuration over here, okay? Or you can do to this diagram, and let's go over. We have 2 electrons in the first level, 2 electrons in the second level, but we have a sublevel P as well over here. So I have more 6 electrons over here, and you're gonna go over until you have 29 electrons, okay? But also you can use the periodic table in your favor. Remember, first you locate it where copper is located at, and then you're gonna start counting. Okay, so I have the first level over here, then we have the second level, third level, and 4. I know the copper is in the 4. So let's count together. And the first level of energy, I only have block S. So it would be 1s, and I have 1, 2. So it would be 1s2. And then I go to row 2, we can call streets, remember? And this streets we have a block S, so 2s, and I have 2 houses over here. And they're gonna keep going in the same street. I have block P, and I have 6, 1, 2, 3, 4, 5, 6 electrons in the block P, so 6 houses. And then we go to 3, so 3, we have block S over here, which has 2 houses, and I go to 3, we still have P, block P, you have 6 houses, and then go to 4. So we're gonna pass to block S, but we have 2 houses, and the copper is located in the D, but look at this. Block D, we decrease 1 level. That means now I have 3 instead 4, because 4 minus 1 will be 3. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's D 9. That is the electron configuration. Good? So if you have to fill out this, let's go let's get back over here and let's fill out this. So I have D9, right? That is the most energetic because it's the last one over here in the spin. So N is in the 3. So it will be 3. And L will be D, which is what? 3 minus 1, which is 2. So it will be 2. And ML, remember, we have from -2, so -1, 0, +1 to +2. So, and I have 9 electrons to go over here, to distribute over here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So ML will be +1. And MS, it will be +0.5. Okay? Good? Okay, so can I have ML equal +3 when I have L equal 2? No, right? Because it will be from +2 to -2, or -2 to +2. Okay, so pay attention on that. Okay, so let's go, keep going on this. So just a reminder how we're going to do the electron configuration, and you write down electron configuration, the last level of energy that include S and P sublevels containing the valence electrons. So I know this element is 7 valence electrons, so I know that is in group 17, right? And if I go to level 3, which is over here, and go to P5, 1, 2, 3, 4, 5, I know we talk about chlorine, okay? So we can have the location or the atoms in your periodic table by the electron configuration, okay? So pay attention on that. And that's all for now.